Hi everyone, today's lesson is part 3 of the Algebra 2 Trig Advanced second semester review. So let's get started. The first question on this set is, we're going to start off on problem number 31. And this question says, assume that cosine of u is equal to 5/13. So what I'm going to do is I'm going to set both of these equal. This will be cosine of u and this will be cosine of v. So we'll make u, let's see here, assuming that the angles are in between 0 and pi, so they're going to be in the first quadrant. So this is going to come up like that, right angle. This one will come also up like that, right angle. For this will be u, this will be v. So cosine of u is adjacent over hypotenuse, and cosine of v is also adjacent over hypotenuse. So this is a 5, 12, 13 special right triangle, so 5, 12, 13. This also is a 5, 12, 13 special right triangle. So our job is to evaluate cosine of u minus v. So we're just going to expand that. So cosine of u minus v is the same thing as saying cosine of u, cosine of v. This is minus, so it's going to be the opposite, plus sine of u, and then sine of v. So for this problem, cosine of u, cosine is adjacent over hypotenuse, so we already know that's 5/13. Cosine of v, so that'll be 12/13, plus sine of u, which is opposite over hypotenuse, so 12/13, times sine of v, which is going to be 5/13. So let's make sure we've got 5/13 cosine. We have 12/13 for sine. We have opposite over hypotenuse, and then we have opposite over hypotenuse. So for this problem right here, all we have to do is multiply 5 times 12. That's going to be 60/169, plus another 60/169, and so that's going to equal 120/169. Problem 32 says, given that cosine of theta is -2/3, so and that it ends in quadrant 2. So here's quadrant 2. So they're saying this angle is going to end right there. So what's going to happen is cosine is adjacent over hypotenuse, and so what we need to do is find sine. So for sine, we're going to expand that, but we do need all three sides. So I'm going to use the Pythagorean theorem. So I'm going to go a squared, so -2 squared, plus, we'll call that x right here, squared is equal to 3 squared. So x squared is equal to 9 minus 4. So x equals the square root of 5. So this will be the square root of 5. To expand sine, we're going to go sine of parentheses 90 minus theta is equal to sine of 90 times cosine of theta minus, because sine has the same sign, sine of theta times cosine of 90. So sine of 90, so remember what sine of 90 is. A couple of ways you can do that. You can think of it like this, being a circle, and here's 90 degrees, and this is 0, 1. And remember how the points go. It goes 0, cosine theta, comma, sine theta. So that means cosine at 90 degrees is 0, but sine at 90 degrees is 1. Another way of doing that is just to graph these. So I also like to graph these, and let me show you what I mean. For sine, the sine wave starts at 0, ends at 0. Cosine starts at 1 and ends at 1. So if I wanted to know what sine of 90 was, and I know from here to here is 360, this is 180, so here's 90, it's 1. So I know this is 1, and of course I could also look at that. Cosine of theta, so here's theta. Cosine is going to be adjacent over hypotenuse, so that's -2/3, minus sine of theta. Sine of theta is going to be opposite over hypotenuse, so that's going to be √5/2 times cosine of 90. Cosine of 90 is 0. Well, 0 times anything is 0, so these are going to cancel out. So I just end up with 1 times -2/3, which is -2/3. All right? The next question says that sine of theta is -4/5, and now I'm in quadrant 3. So 1, 2, 3. So now I'm down here. So my graph is looking down like that, okay? And it says that sine of theta, this being theta, my reference angle, is -4/5. So this is opposite over hypotenuse, which means that this is -3 because it's a 3, 4, 5. As long as 5 is my hypotenuse, I'm good. For these right here, what they're asking me is to expand these. Now, there's formulas that you will need to know. For sine of theta, that's 2 sine theta cosine theta. And so cosine, my favorite one is 1 minus 2 sine squared of theta. And then for tangent, tangent's just sine over cosine. So tangent does have its own formula, but I can still use whatever I get for sine of 2 theta over cosine of 2 theta. So for this one, we're going to go 2 times sine of theta. So sine is opposite over hypotenuse. So this will be -4 over 5. Cosine of theta will be -3 over 5. And so multiplying these out, straight across, I'm going to get 2 times 4, which is 8. 8 times 3 is 24, all over 25. So this one is sine of 2 theta. For cosine of 2 theta, I'm going to go 1 minus 2 times sine squared. Now sine is opposite over hypotenuse, so this is -4/5, but don't forget that that's squared. So this will be 1 minus 2 times 16 over 25. And so that's going to be 1 minus 32 over 25. And so for this problem right here, I am going to multiply this by 25 over 25 so that I could get a common denominator. And so 25 minus 32 is -7 over 25. So this right here is cosine of 2 theta. Now, we have 3 formulas for that. You can use any of them. So this is just the one I like to use. Now, for tangent of 2 theta, I'm going to take that sine over cosine. So realistically, what I have is that, which is 24 over 25 divided by -7 over 25. And my 25s will cancel out when I multiply by the reciprocal, so I end up getting -24 over 7. And that's tangent. Now, the last part of the question says, what quadrant does 2 theta lie in? So what you do need to do is you're going to need to figure out what theta is. And so for this, I know that theta, you have to take this up here. So you end up getting, so start with sine theta equals -4/5. And then I would go theta is equal to arc sine of -4/5. And I believe the answer is approximately, what did I get? 53 degrees. So I think I got 53 degrees, which means that this angle right here is your 53 degrees, okay? So if you were to go 180 plus 53, you're going to get, so 100 theta is equal to 180 plus your 53, because this theta is my reference. Then we get theta is equal to 233 degrees. So they want to know what quadrant am I in. For this problem, I'm in quadrant, let's see, 2 theta. So I have to multiply this by 2. So let's see here. This times 2, because it says 2 theta, is going to be 466. So what I actually need to do is go around. So I'm going to go from here all the way around. That's 360. So subtract 360, I get 106. So now I have to add another 106, and now I'm here. So what quadrant am I in? I'm in quadrant 2. So these problems right here are proving identities. So for the first one, I'm going to, let's see, I'm actually going to just try to set these, I'm going to transfer these to sine and cosine. So cosecant is 1 over sine of x, minus cosine is just cosine of x, and then cotangent is cosine of x over sine of x. And I do notice that both of my denominators are the same. So what I see is 1 minus cosine squared of x over sine of x. And 1 minus cosine of x is one of my Pythagorean identities. So that's just sine squared of x over sine of x. And this is the same thing as saying sine of x times sine of x over sine of x, of course, and one of these will cancel, right? And so I'm left with sine of x, and does that equal sine of x? Yes, check. This one right here, you would just bring all the way down. And so you do get these to equal. For this one right here, this says sine x plus cosine x, and this is quantity squared. So I think what I'm going to do with this is actually square them. So we're going to get sine of x plus cosine of x times sine of x plus cosine of x. So then we're going to multiply this out, or FOIL. We're going to get sine squared of x plus sine of x plus sine cosine. So that'll be 2 sine x cosine x, and then plus cosine squared of x. Now, I do know that sine squared of x plus cosine squared of x is 1. And so that's 1 plus 2 sine x cosine of x. And then this right here is one of my double angles. So that's 1 plus 2 sine, sorry about that. 1 plus sine of 2x. And, oh, that's what I'm trying to prove. And so 1 plus sine of 2x. And then these equal to each other. Perfect. So for this problem, we're going to prove the identity cosecant of x plus cotangent of x squared, quantity squared, is equal to that. So what I'm going to do first is going to change these to sine and cosine because these are both in sine and cosine. I'm going to see what happens when I do that. So the first thing we're going to do is we're going to say, well, cosecant is 1 over sine of x plus cotangent is cosine of x over sine of x. Okay, so now I have a common denominator. So I have 1 plus cosine of x all over sine of x. So what I think I'm going to do with this is I'm going to square both the top and the bottom. And in doing that, I'm going to get, 1 plus cosine of x times 1 plus cosine of x. And then on the bottom, I'm going to have sine squared of x. And the reason why I needed to do that was because I have this on the denominator, and the only way I'm going to get that sine squared into a cosine is to change it into one of my Pythagorean identities. So this right here on sine squared, this right here is actually 1, it's 1 minus cosine squared. So this is 1 minus cosine squared of x. So that means that that's a difference of 2 squares. So that's going to be, let me rewrite this, 1 plus cosine of x times 1 plus cosine of x all over 1 minus cosine squared, which is 1 plus cosine of x times 1 minus cosine of x. And then my 1 plus cosines of x's are going to cancel, and I'm going to be left with 1 plus cosine of x over 1 minus cosine of x, which is, see that right up here, what I want to prove, 1 plus cosine of x over 1 minus cosine of x. So check. The next identity is this right here. And I think before I solve this one, I'm going to try to simplify my denominator. And in doing that, let's see, we're going to go 1 plus sine of x all over this right here, which is 1 minus cosecant is going to be 1 over sine of x. So for this one, let's see, I'm probably going to combine my denominators on here. So I have sine of x over sine of x. And so that's going to give me 1 plus sine of x over sine of x minus 1 over sine of x. And division, of course, means multiplying by the reciprocal, which is this right here. So that's going to give me 1 plus sine of x divided by this. So that means it's times sine of x over 1 plus sine of x. And wow, well, this looks like these two terms here and here are going to cancel out, and I'm going to end up getting sine of x. Well, and that's all I'm done. That is not equal to this. So what I'm going to do is simplify this and see if that equals sine of x, because tangent of x is sine of x over cosine of x divided by, so that's divided by secant, which is 1 over cosine of x, and that's going to be sine of x over cosine of x times the reciprocal, which is going to be cosine over 1. So cosines are going to cancel, and I do get equal to sine of x. So check. Next question says, find all the solutions. So all solutions is going to be like plus pi n, 2 pi n meaning over, you're multiplying by 1, then 2, then 3. What I see for this problem right here is I'm trying to solve for cosine of x. So what I'm going to do first is divide by 4. So I'm going to get cosine squared of x is equal to 3 over 4, bless you. And I'm going to square root both sides to get rid of this root, or to get rid of the square. So I get cosine of x is equal to plus or minus the square root of 3 over 2. And so what this is asking me is, where is cosine? Let me fix that. So that's going to be x equals arc cosine of root 3 over 2. And it's also going to give me x equals arc cosine of negative root 3 over 2. And so what that would give me is all the values where that is equal to. So cosine is positive root 3 over 2. So cosine is adjacent over hypotenuse. So there's 1. So here's your theta, or x. And where we're at is a 30-degree reference. So we're at a 30 degree. So all my 30 degrees, so either in the first quadrant, because we're doing both positive and negative, all students take calculus, everything's positive here. So this would be my 30 degrees, going to be my pi over 6. We also have in this quadrant, cosine is negative, so that's 5 pi over 6. We also have in this quadrant 1 and 1/6, 1 and 1/6, so that's 7 pi over 6. And then we have in the last quadrant, all the way down here, is 1 and 5/6. So what's 1 and 5/6? 11/6. So that's 11/6 pi. And because we asked for all solutions, so if I had asked for solutions that were from 0 to 2 pi, okay, then this would be my answer. But because I asked for all solutions, then you would take these answers, and each one of these would be pi over 6 plus, because a period for cosine is 2 pi n, so plus 2 pi n, or 2 pi k. And then you would go 5, 6 pi plus 2 pi n. So like every 2 pi, and you would just keep going and going and going, every one, for both of these as well. So for problem number 39, it says find all the solutions that are on the interval from 0 to 2 pi. So what we're going to do is, I noticed that we have signs on both sides. It is quadratic, so we do need to set it equal to 0. So we have 2 sine squared of x minus root 2 sine of x is equal to 0. What I'm going to do is factor out a sine. So in factoring out a sine of x, we're left with 2 sine of x minus the square root of 2 is equal to 0. And now that I'm set equal to 0, I'm going to set both of these equal to 0. So I have sine of x equals 0, and 2 sine of x minus root 2 equals 0. So 2 sine of x is equal to root 2. Divide by 2, I get sine of x equals root 2 over 2, and x is equal to arc sine. When moving this over to the other side, use arc sine of root 2 over 2. And this one is x equals arc sine of 0. So what we're going to do here is we have two parts. We're asking ourselves, where is sine equal to 0? So if I were to graph it this way, and I make my sine wave 0, it's 0, It's here 0 at pi, and it's here 0 at 2 pi. However, because see the parenthesis here, that means that that's not included. So we have 0 and pi. So x equals parenthesis. We have 0 so far and pi. For this one right here, we're going to figure out where is sine root 2 over 2. And that stems from a 45-degree reference, which is 1 over root 2. So meaning if I was at 45 degrees, and this is positive, 1, 1, square root of 2. They want to know, where am I? Well, first I'm at a 45-degree reference. But if you remember, all students take calculus. In this quadrant, all are positive. And so that means 45 degrees, that's going to be a pi over 4. And in sine is positive in the second quadrant. So here also, where am I? Where I am is a fourth reference, which means that's 3/4. So this will be 3 pi over 4. Okay. These two quadrants, no, because both of those quadrants sine is negative, and because it's sine of root 2 over 2 and that's positive, you can't be in the bottom two quadrants. The next question says, find all the solutions. So we have 2 sine of x, another quadratic, and in an interval from 0 to 2 pi again. I'm going to set everything equal to 0. So we have 2 sine squared of x minus 3 sine of x plus 1 equals 0. And for this problem, I am going to factor and set that equal to 0. So I get 2 sine of x minus and a minus. And this will be just sine of x. And let's see, that'll be -2 and -1 makes -3. So we're going to split this up and set them both equal to 0. So sine of x minus 1 equals 0. Sine of x equals 1. X equals arc sine of 1. This will be 2 sine of x minus 1 equals 0. 2 sine of x equals 1. Sine of x equals 1/2. X equals arc sine of 1/2. So a couple of things what we're doing here is we're trying to figure out where is sine positive 1/2. So remember, all are positive in the first quadrant, and sine is positive in the second quadrant. So that means that I'm looking for opposite over hypotenuse. That means root 3. So opposite, the angle opposite of 1 is 30 degrees. So 30 degrees, and because I'm in x here and pi here, that's telling me, and I can't just say 30 degrees and this being 150 degrees. You wouldn't say that because you're in radians. So 3 goes into 186 times, so that is a pi over 6. So for this one, we're at pi over 6. And 150 degrees, think of it like this. If from here to here is 1 pi, and we're 1/6 short, therefore, this from here to here has to be 5/6. So this is 1/6 and 5 pi over 6. Okay. Where is sine equal to 1? Now, a couple ways to do that. Again, using your circle. This is 1, 0. This point is 0, 1. This point is -1, 0. And this point is 0, -1. Remember, it always goes cosine first, then sine second. So where is sine 1? It's here. And where am I? I'm at pi over 2. But keep in mind, I really encourage you to draw the sine wave just for visual. Where is sine 1? Here's 1. Where is sine 1? It's here. Where are you? You're right there. So if this is 2 pi and this is pi, then this is a 1/2 pi. So my answers would be in solution sets, we'll go with pi over 6, pi over 2, and 5 pi over 6. So the next question says simplify all of these expressions. So remember that if it's an equation, you don't have those restrictions of the inverse restrictions. But if it is not an equation and it's an expression, you have restrictions. So be careful of that. Remember, let me review with you what those restrictions are. Okay, for sine Sine can only be from negative pi over 2 to pi over 2. This is sine, arc sine. Cosine, arc cosine can only be from 0 to pi, and that's arc cosine. And tangent can only be from not including negative pi over 2 to pi over 2. So those are my restricted domains. You've got to be very careful with that. So for arc cosine of 0, they're saying where is cosine 0? But you have to be from 0 to pi. So here's your area here, restricted domain. So you've got this value is 1, 0. This value is 0, 1. And this value is negative 1, 0. So where is cosine 1? It's here. Excuse me, where is cosine 0? It's here at pi over 2. So this is pi over 2. Where is tangent negative root 3? Remember, it has to be from only in quadrants 1 and 4. So therefore, it has to be down here because tangent's negative. Everything's positive in the first quadrant. Tangent being opposite over adjacent. Opposite the root 3 is 60 degrees, which is pi over 3. You cannot just say pi over 3 because remember, you're going down. And so this is going to be negative pi over 3. Arc cosine, this is the same thing as saying arc cosine of negative, where is cosine? Negative 1. Again, cosine can only be from here to here. And so for this point right here at negative 1, so you remember from the first picture, that's going to be equal to pi. And this is pi over 3, pi over 2. Okay, so this one has a restriction first. Where is tangent root 3? So we know that it's a pi over, because it's 60 degrees, we know it's a pi over 3. But because it's a positive, we know it's in the first quadrant at pi over 3 because that's 60 degrees. So this is pi over 3, or 60 degrees. But this is then saying what is sine of pi over 3? So sine being opposite over hypotenuse is going to be root 3 over 2. This one is saying, remember this is a restriction, where is sine 1/2? So sine is 1/2, and remember sine can only be in the first and fourth quadrant. So because 1/2 is positive, sine 1/2, so we're at the 30-degree reference, or pi over 6. And then this is saying, well, what is cosine of pi over 6? Well, that's going to be root 3 over 2. This one is saying, where is cosine positive root 2 over 2? Remember, cosine can only be in 1 and 2 quadrants. And because it's positive, it must be in the first quadrant. So that's 45 degrees. 45 degrees or pi over 4. So it's at pi over 4. And then this is asking me what is sine of pi over 4? Well, sine of pi over 4 is root 2 over 2. The next question is saying what? See, if it's just cosine or sine or whatever, that's saying what. If it's an arc, that's saying where. Okay, so when it says what, they're looking for an actual numeric value. So what is cosine of pi over 3? Pi over 3 is in the first quadrant, 60 degrees. This is root 3. This is 2. This is 1. This is 1/2. So this is saying where is sine? Where is sine 1/2? So sine is 1/2, not at 60 degrees. It's at 30 degrees. So that would be at pi over 6. And lastly, this is saying what is sine of 7 pi over 4. There's no restriction because it's not an inverse. So 7 pi over 4, I like to do it like this, 1 3/4 pi. That's what that is, 7 pi over 4. So let's graph that. That's 1, and then 3/4 is down here. So 3/4, 4 goes into 180 45 times. So this is a 45 degree. So this is saying what is sine at 45 degrees reference in the fourth quadrant. And so that's going to be, all students take calculus, only cosine's positive, so that's a negative root 2 over 2. And then it's saying, once we have that, then it's saying where is sine negative root 2 over 2 with a restricted domain. So that's going to be from here, sine, that's not right. So sine is restricted from 1 to 4. So where am I? If it's negative, I'm actually in the fourth quadrant. So you can't say 7 pi over 4 because remember, sine can only be from negative pi over 2 to pi over 2. So to get down here, you would say negative pi over 4 because remember, you can only go from here up or down. You can't go outside of your restricted area. So that's it. So negative pi over 4. So the next question says, what is the equation of this circle that has a radius of 5 and it has a center of 2 down 3? So here's 2 comma negative 3 and my radius of 5, well, that's there. Remember the equation x minus h quantity squared plus y minus k quantity squared is equal to my radius squared. So we have x minus 2 quantity squared plus y plus 3 quantity squared is equal to 5 squared, which is 25. So this is the equation of my circle, and that's in standard form. The next question is saying, find the center, vertices, and foci. So you need to realize what these are. The first problem is plus plus, so that's going to be an ellipse. And for this one, my center is going to be at 5 comma negative 3. So over 5 down 3. In the x direction, you go the square root of that. So the square root of 1 is 1. So I'm going to go 1 in the x direction. In the y direction, I go the square root of 36, which is 6. So I'm going to go up 6, down 6. And then I'm going to connect my dots because it is an ellipse. And the last thing they asked me to do is to find my focal points or my foci. And to find my foci, I'm going to use this formula. C squared equals a squared minus b squared. So c squared is equal to a being positive. Hold on. A being the bigger number, because in an ellipse, a is always greater than b. So we're going to go 36 minus 1, square root of that. So c is equal to the square root of 35, plus or minus. So therefore, if my center is at 5, negative 3, my focal points are going to be up here and down here. So they're going up on the y-axis. So this point right here will be 5 comma negative 3 plus the square root of 35. And this point down here for my focal point will be 5 comma negative 3 minus the square root of 35. For this problem, this is a hyperbola because we have a negative value. So you have negative x squared plus y minus 1 quantity squared over 4 equals 1. What this looks like here, let me rewrite this just one time here. This is actually negative x minus 0 quantity squared over 1 because there's no value there, so it's got to be 1. My center this is a hyperbola, and my center is going to be at 0 comma 1, so it's right here. In the x direction, I'm going to go 1. In the y direction, I go the square root of 4, which is 2. And don't connect the points because what you're looking for is a hyperbola, which you're going to connect the box and create your asymptotes, which are going to be inside here. And whatever axis is positive, so my y-axis is positive, that's the axis my graph is going to go, my hyperbolas are going to go off of the y-axis. So they're going to arc up like this, and this one's going to arc down like that. Okay, and then my focal points, the last part is going to see where's your focal points. Well, the focal points are always cut in the arc. And so we're going to use this formula, c squared equals a squared plus b squared. So c squared is equal to 4 plus 1, which is 5. So c is equal to plus or minus the square root of 5. So what I have to do, because my center is at 0 comma 1, my focal points are going off of my y-axis. So this point is going to be 0 comma 1 plus the square root of 5, and this point right here will be 0 minus the square root of 5. And then, let's see here. Oh, excuse me, that's not right. It'll be 0 comma 1 minus the square root of 5. And lastly, I need my asymptote equations. I know they didn't ask for that, but you will need to know what those are. So based on 0, 1, you always start off y equals plus or minus the rise over the run x. And so that's going to be the square root of 4 over the square root of 1, which is 2. Now, the difference is because my center has been moved. This would be my asymptote equation if my center was at 0, 0, which it's not. So because my center has moved, then I have to make allowance for that. So that'll be y minus 1 equals plus or minus 2 times the quantity x minus 0. And so those are my equations. That's my equation of my asymptote for this problem because the center has been moved. The next question says, find the standard form of the equation of the parabola and graph the parabola given the information. So for this first problem, it says that you have a vertex at 4, 2. So we're going to go over 4 and then up 2. So there's the vertex. I like to put a V there or an F depending on the focus. And this one says that my focus is 4, 0, so there's my focus point here. So what that means is the distance between my focus and my vertex is 2. So that means P is equal to 2. That's my distance between my vertex and my focus. So because the parabola always has to cup the focus point, your graph is then going to go like this, and it's going to drop down, okay? So we know then, because it's either up or down, it'll be a y equals. So this will be a y equals negative x squared graph because it's going upside down and it's vertical. So I'm going to, from here, this stems from y minus k is equal to a. Remember, the a is actually 1 over 4p times the quantity x minus 0, or x minus h, quantity squared. So because that this is dropping down 2, that makes that distance a negative 2. So that means that value is going to be negative. So my vertex being at 4, 2, we're going to go y minus 2 equals 1 over 4 times p is negative 2, times the quantity x minus h. So x goes with the 4, so minus 4 quantity squared. So this equation right here is going to go y equals negative 1, sorry, let me fix that. Y minus 2 equals negative 1/8 times the quantity x minus 4 squared. So this is in vertex form, but just keep in mind there's a lot of ways that you could write that. For example, I could multiply this 8 over here, and then I would have y minus 2 equals negative times the quantity x minus 4. And so this would also be okay. Going back to the top, I could also just simplify for y and have that negative 1/8 times the quantity x minus 4, quantity squared, and then add 2. So all three of these are sufficient. They're completely fine ways of writing the standard form of the parabola. For this problem here, let's see. For this problem, this says given the vertex and the directrix. Okay, so in doing that, my vertex is 0, 2, so that's going to be right here. So that's a vertex. My directrix is x equals negative 3. So that's a line that goes through the x-axis at negative 3. So that looks like this, okay? And this is negative 3. So that means my p distance, this distance from here to here, my directrix to my vertex, is actually 3. Also, I know that this is my vertex, my directrix. My vertex, my parabola is going to go like that. So this is, if it's a y equals x squared, it goes up or down. But if it's an x equals y squared, it's going to go to the right or to the left. Left if it's negative, but this is positive. So that means it's going to be x minus h equals 1 over 4p times y minus k, quantity squared. So I know that p is 3, and I know my center, my vertex is at 0, 2. So this goes with x, this goes with y. So this would be x minus 0, or just x, equals 1 over 4p, p is 3, times the quantity y minus 2, quantity squared. So just simplifying that, I'm going to get x equals 1 over 12 times the quantity y minus 2 and this would be my equation of my parabola. However, just keep in mind, again, see this 12 down here? I could multiply it like that and make that 12x equals y minus 2 quantity squared, and that's also a completely fine way of writing the equation. The next question says, find the equation of the asymptotes of the hyperbola. Well, this is not a hyperbola. This is a hyperbola. This one is a parabola. So for this problem right here, I'm wondering if they meant to say this is quantity squared. So I'm going to put a 2 here because find the equation of the asymptotes. I think that they meant that this must be a hyperbola. So I'm going to put the quantity squared there. I know that my center is at 0, 0. I know in the x direction I'm going to go the square root of 4, which is 2. In the y direction I'm going to go the square root of 9, which is 3. And then I'm going to make my box that goes around this. And then I'm going to write in my asymptotes, which go like this. Now, if my center, if my center is at 0, 0, the equation of the asymptotes is pretty simple. It's just that value up over, so rise over run. So it's like 1, 2, 3 over 2. So it would be y equals rise, 1, 2, 3. It's the square root of this over the square root of this. It's the square root of 9 over the square root of 4. Always, okay, plus or minus, it's always the rise over the run, and you know that. So we know that it'll be plus or minus 3 over 2, and then x, because it is an equation of a line. The difference is when the center is off 0, you would move it. So this is basically x minus 0, see that? And then this would be y minus 0. And so it's just y equals plus or minus 3/2 x. And that's the equation of my asymptotes for this problem. Let's find the equation for the asymptotes for this problem. But before I do that, I actually need to complete the square to solve and put it in standard form. So I am going to start by grouping my x terms. So I'm going to go negative 3x squared minus 12x. And then I'm going to group my y's. So 2y squared plus 8y is equal to negative 2. I am going to complete the square because I have an x squared term and an x, and I have a y squared term and a y. So first I need to factor out this and this. So we're going to go negative 3 times the quantity x squared plus 4x. Half of 4 is 2. 2 squared is 4. Plus 2 times the quantity y squared plus 4y, half of 4 is 2, 2 squared is 4, is equal to negative 2. But keep in mind, if you added something to the left side, you still have to add that to the right. And because I temporarily factored out this negative 3 times 4, that'll be negative 12, and 2 times 4, which will be a positive 8. So that looks like it's negative 14 plus 6, plus 8, which is negative 6. So let's see, we got negative 3 times the quantity x plus 2, quantity squared, plus 2 times the quantity y plus 2, quantity squared, is equal to negative 6. And so I'm going to divide everything by negative 6 to get that to be 1. So divide everything by negative 6. And so I end up getting x plus 2 quantity squared over 2 minus y plus 2 quantity squared over 3 is equal to 1. So for this problem right here, all I have to do is try to find out what is the standard form. Oh, they're only asking for the standard form. But just for fun, because why not? It is a review. Let's find the equation of the asymptotes. So remember, we start off like this. Y equals plus or minus the square root of the rise over run x. So that'll be 3 over 2, right? And then because my center has moved, see my center is at negative 2 comma negative 2, then this is going to change. So this goes with y, this goes with x. So I'm going to go y minus or plus 2 equals plus or minus the square root of 3 over the square root of 2, and I would simplify that, of course, and then x plus 2. Just keep in mind, if my center was at 0, 0, this would be the equation of my asymptotes, okay? But because my center is not at 0, 0, my equation of my asymptotes would be this. But the actual question says just what's the standard form? So the standard form is that right there. So the next question says, find the standard form of the equation of the ellipse and graph. So what we know is that my vertices are at 0, 1, and they're at 4, 1. So 1, 2, 3, 4, 1. So those are my vertices. That means that that's my axis. That's my major axis. When they give me my vertices in an ellipse, those are my major axis. Okay, so that means that the major axis length is 1, 2, 3, 4. So that means that halfway in between, 1, 2. This is my center. And where am I? I'm at 2, 1. And then my cota vertices are at 2, 0 and at 2, 2, which means that distance is 2. Okay, so let's look at it like this. My center is at 2, 1. So we're going to go x minus 2 quantity squared plus y minus 1 quantity squared equals 1. Now, underneath these, in the x direction, I went 2 to the left and 2 to the right, so that makes that 4. In the y direction, I went up 1 and down 1, so that's 1. So that's just my equation of my ellipse in standard form. For the next problem, I know my vertices are at 2, 0. So here's 2, 0. And I have 2, 4. So 1, 2, 3, 4. So here's my other vertice, okay? So that means, again, this is my center right in the middle there. And that's going to be 2, 2. So that's my center, 2, 2. In the y direction, this distance here is 2. But let's see. Okay, so let's start off. We know we have x minus 2 quantity squared plus y minus 2 quantity squared is equal to 1. So in the y direction, I went up 2 and down 2. So that means that 2 squared is 4, so there's 4. But in the x direction, let's see, where's my foci? Let me figure out where my foci are. They're at 2, 1 and at 2, 3. So what that's telling me is that my foci, C value is equal to 1. So remember, for focal points, it's c squared equals a squared minus b squared. A in an ellipse is always greater than b. So for this value here, c squared, which is going to be 1, is equal to 4 minus my b squared term. So it looks to me like if I subtract, well, if I move the b squared over here, I get b squared is equal to 3. So that value here is 3. And that's it. So there's my equation of my ellipse for this problem. Find the vertex, focus, and directrix. Big clue is that that's a parabola. Anyway, another clue is that it's an x squared term. So, and I don't have 2 squared, so it's only going to be 1 squared term. Let's see. It's an x squared, so I'm going to move that to the other side. So I have 6y minus 2 equals negative x squared minus 4x. I'm just going to leave it like that and factor out that negative sign. So 6y minus 2 is equal to negative times the quantity, x squared plus 4x. Now, completing this square, because remember you have to take that value out first, the factor, we're going to take half of my b term, so half of 4 is 2, 2 squared is 4. But you have to add the same value. So if I temporarily factored out a negative sign, when I add that to the left side, that has to go back in as negative 4. So far I have 6y minus 6 equals negative times the quantity x plus 2 quantity squared. Factoring out a 6, I get y minus 1 equals negative times the quantity x plus 2 quantity squared. And this is acceptable. My vertex for this problem is going to be negative 2, comma 1. So negative 2, comma 1. So there's my vertex. It is a y equals negative x squared graph. Y equals negative x squared graph, which means that it is going to go down. So therefore that my graph will drop down like that. And when I'm trying to find because it wants the focus and the directrix, what I'm going to do now is this. Y minus 1 equals negative 1/6 times the quantity x plus 2, quantity squared, because this value right here is my equal to my a value. And remember, a is equal to 1 over 4p, which means that this is equal to 1 over 4p. So negative 1 over 6 equals 1 over 4p. Cross multiply. Negative 4p equals 6. P equals negative 6 over 4, which is negative 3 halves, or negative 1.5. So that means that my focus from here is going to be down 1.5 points. So that means that that value is negative 2 comma negative 1/2. And my directrix will be 1.5 up from here. So there's my directrix like that. Okay, and the equation of that, if this is 1, and I'm going to go up 1.5, so that's 2.5. So that'll be y equals 2 and 1/2, or just 5/2. That's either one is fine. So the next question says, determine what kind of conic this is. So you don't have to complete the square in order to figure out what kind of conic it is. If these two values are the same, then it's a circle, but they're not. See how they're both x squareds and they're both positive, but they're different. These values are different, so that means that's an ellipse. Anytime you have a negative sign with your two squareds, that's a hyperbola. And then we have 2x squared, y squared, but these values are the same. So that's a circle. And I have one squared term, that gives me a parabola. The next question says, solve the system algebraically. What it looks like right here is that because I have one squared term, that's a parabola. And here, I have two squared terms, but a minus. This is a hyperbola. And so I like to graph these personally. So we're going to graph this first. This being a hyperbola, I'm going to get x squared over 64 minus y squared over 64 is 1. That means my center is at 0, 0. And underneath that, in the x direction, I'm going to go 8. And in the y direction, I'm also going 8. And so I'm going to make a square here like this. And I'm going to put in my asymptotes like that. And remember, whichever axis is positive, whichever variable is positive, that's where your axis is. So because my x squared is positive, my graph is going to go like this to the right, and also like this to the left. Okay, now for this problem, that's a parabola. And so let's see what that would look like. For this problem, I'm going to go negative 16y equals negative x squared. I'm going to get 16y equals x squared. Y is equal to 1 over 16x squared. So this is a y equals x squared graph. So that's going to go up. It also means that, let's see here, 1/16, it's probably pretty wide. 0, 0 here. So not really sure how wide it is and how many intersection points. It kind of looks like I might have 2 on the left and 2 on the right, but I'm just not sure, and so I do need to plug those in. So I might just have 1, or I might have 2. So what I need to do here is simplify, and let's see. I have an option. I can subtract the equations so that my x squared terms leave, or I could say, well, x squared is equal to 16y, and then because that's what x squared is, I could plug it into this equation. And then I would have negative y squared plus 16y minus 64 is equal to 0. I'm going to divide everything by negative 1. So I get y squared minus 16y plus 64 equals 0. This will be y minus 8 times y minus 8 is equal to 0. Or y minus 8 quantity squared equals 0. Square rooting both sides, I get y equals plus or minus 8, or I get 8. Y square root both sides, I get y equals 8. So I'm going to plug in plus or minus 8. Let's see, if I square root both sides, I get y minus 8 equals 0. Oh, just y equals 8. Okay, so now y equals 8. I need to plug into my other equation. So my other equation, let's see, what did I solve for this one? So we know that x squared minus 16y is equal to 0. So we said y was equal to 8. So we have x squared minus 16 times 8 equals 0. Let's see, for this problem, 16 minus 8, what is that? 128? It's 128. So x squared is equal to 128. So x is equal to the square root of 128. 64 times 2 is 128. So that's going to be 8 root 2 plus or minus. So my values, so my intersection points are going to be, okay, so when I've got x, I've got 8 root 2 comma 8. And I have negative 8 root 2 comma 8. So those are my x, y's. Cool. Okay. A couple of these, calculate 10 combinations of 3. So this is from probability. So the formula for C combinations is if you had NCR, remember it's n factorial over r factorial, and then n minus r factorial. So that would be 10 factorial over 3 factorial, and then 10 minus 3 factorial. So that's actually 10 times 9 times 8 times 7 factorial over 3 times 2 times 1 times 7, 10 minus 3 is 7 factorial. So these end up canceling. 3 divides into 9 3 times, 2 divides into 8 4 times, 3 times 4 is 12 times 10 is 120. So I get 120 for this value here. Permutations, that's NPR. That's the same thing as saying n factorial over n minus r factorial. And so this would be 10 factorial over 10 minus 3 factorial, which is 10 times 9 times 8 times 7 factorial over 7 factorial. 7's cancel. 9 times 8 is what? 72 times 0, 720. How many 7-digit phone numbers can be formed? So we have 1, 2, 3, dash 1, 2, 3, 4. The first 3 digits cannot be 0 or 1. So that means out of the 10 digits, these have to be 8. So 8 times 8 times 8. And these last ones would be just 10. Now, I personally know that this is actually going to be 9,999 because all phone numbers cannot have 4 zeros at the end. But anyway, 8 times 8 times 8 times 10 to the 4th power. Lastly, it says, how many different ways can the word Pacific be arranged? So we have 1, 2, 3, 4, 5, 6, 7 letters, and then you put your repeating letters on the bottom. So it looks like I have 2 I's, so that'll be divided by 2 factorial. I have 2 C's, so that'll be divided by 2 factorial. So that's 7 times 6 times 5 times 4 times 3 times 2 all over 2 times 1 times 2 times 1. And 2 times 4, that's 4. So my answer would be whatever 7 times 6 times 5 times 3 times 2 times 1 is. So that concludes my Algebra 2 Trig Adv second semester final review. So you have 3 parts to the review, and I wish you the best of luck on the review. And just some words of wisdom, moving on to the next level of class is trust your first instincts always. Find your inner strength. We all have it. You need to find yours, and you'll know when you have it. Only you can allow someone else to hurt your feelings. I really believe that. And challenge yourself often. If you see you're getting bored, challenge yourself. Go do something different. All great future ideas should seem ridiculous at first. Completely believe that. So those are my words of wisdom. I wish you the best in your endeavors in your future. Thanks for watching, and I certainly hope this helped. Let me know if it helped you. All right, thank you.